Okay, you're probably looking at this picture right now and going, my God, what has happened to this radio? This is one of those two Teaberry Ranger tees I'm working on for a customer. This is the one that had a bad display segment. Just want to do a really quick overview, and I'm really quick, because I want to get too in-depth in this, take up, an hour of your time, just, describing something as simple as a LED 7-segment display. But just a few tips. Tips when you're, for starters, disassembling the radio to get into this stuff. If, like in the case of this radio, I could not get this knob off with my bare hands. And I've got some vice grip fingers. I mean, I can latch on to stuff that most people can't get off, and I've got really good grip. I still could not get this knob off, even getting in with 3 or 4 fingers, and I tried both hands, pointer and thumb, from both hand in there, the radio wedged between my legs trying to get this off. It was just plain stuck on there. So if you run into something like that, what I did to get it off was I used soft jaws. These are actually pliers meant for pulling vacuum tubes. But now, the handles are kind of flimsy. They're only meant for pulling glass tubes. But I find they work good on these knobs because I can grab the knob. And let me reach over here. Turn down my bench radio. Anyhow, I can grab them with these jaws. And then I'm not going to grab them by the handles. I just grab them by here, and I can get my whole hand here and squeeze it really hard. And that's how I was able to finally get this off. I was able to finally get the knob pulled off. But worst case scenario, if you cannot get the knob off, and you can't get the radio apart, the faceplate off, without getting this knob off. So it's one of those things, it has to come out. You don't have a choice. There's no way to get to what you need to. You can't remove the channel selector till the knob comes off, because the nut that's retaining it to the steel bracket is behind this plastic plate, which is behind this knob. So, it's one of those cascade problems. Can't get the knob off, can't do anything else. So your last resort is, if you can't get this critter off, is a screwdriver. And like I say, this is a last result. Last option. You're going to want to get in behind it and try and pry it off. Now, try not to be tempted to twist it, because if you twist the screwdriver, that sharp edge is either going to dent or crack the plastic. The other thing is, on the edge of the faceplate, you're going to be prying against that. You don't want to do that. You never want this metal screwdriver blade to come in contact with this plastic bezel. Take something like a pack of paper, notepad. I usually have a dozen or so of these packs of Post-it notes laying around all over the place. Put that up against the faceplate, and then lay your screwdriver on that. Get the screwdriver underneath the knob, and you can pry up on that. But that way, the screwdriver, or the wad of paper, is in between the screwdriver blade and your plastic bezel, so you don't damage this. Because in the case of this radio, you're never going to find another one. Other things, once you get, and you may end up with 2 screws on each side holding the plastic bezel, and then 2 screws on each side holding the metal faceplate bracket, or in the case of this one, it just had 2 screws on each side and that was it. If you take the screws off and everything's falling apart, but this plastic faceplate still will not come off of this metal bracket, stop. Don't get in there and pry on this bezel trying to get it off of this front faceplate bezel bracket. You're going to break it. There are some, like in the case of this radio, has 2 more screws. They go in one. I got a flashlight. See that little hole right there? Right down in there. That little hole, and then there's another one right down in there. There was 2 screws, one in there and one in there. These screws go through this metal bracket into the back side of this faceplate and hold it on. So take those out first. Then once you get that out, the channel selector switch, which I had in the case of this radio, I had to take it out to gain access to the 2 screws that hold this plate on. That'll have, in this case, it was a 1/2-inch nut and a star washer. Take that off, pull the channel selector out. Then I was just barely able to squeeze down in here with a Phillips screwdriver to get the 2 other screws, retaining screws, that hold the channel display board in, and then get it extracted. Now, common problems with displays. Problem might not be the display itself. It can be a bad channel selector switch. It can be a bad resistor network, can be a bad display, or in the case of this radio, it actually needs no parts whatsoever to fix it. It's just bad solder connections. So it's not uncommon in radios this vintage for resistor networks to go bad. Now, what a resistor network is, there's two different types. There's SIP and DIP. SIP, S-I-P, stands for single inline package, which is what this radio has. If you look down in here on this channel selector board, see this long black thing with a shitload of pins sticking out the bottom of it? That's actually a block that's a bunch of resistors all in one package. That's why it's called SIP, single inline package. Now, your other style, and you usually don't have problems with these. These are usually, as long as they didn't burn up, wire shorted out or something and it got overloaded. They usually don't go bad. But the early DIP package resistor networks were known for going bad. A DIP package looks like, now this is the PLL chip down here, but that's what a DIP package is. That stands for dual inline package. It has 2 rows of pins. If the resistor network looks like that's attached to this board, there is a chance it's bad. So you can go in on the back side of the board and check, turn your channel selector, check that you're getting the voltage or ground is passing through each one of the resistors in that. Now, network resistors like that come in 2 major styles. Either what I call straight pass-through, or there'll be a common style. They'll use a common tie point. So in one instance, which you don't really see in CB radios very much, one pin of that DIP package will be common, and every other pin then will have a resistor internally tied to that common pin. Most of them aren't like that, and that's a good thing. Most of them are this style, what I call pass-through style. One side is one side of a resistor. The pin that's directly across from that is the other side of that same resistor. They don't have a common tie point. It's just basically a bunch of individual resistors inside. So if one of these goes bad, you don't have to use a DIP network resistor package to replace it. You can just use individual resistors. Just get yourself some like 1/8 or 1/4 watt resistors of the proper, and usually the resistance will be printed on the network resistors like this. You can just get individual resistors and just replace them with individual like 1/8 or 1/4 watt resistors. Will work just fine and a lot easier to find than some of these network resistors. If that's not the problem, like I say, it can be the channel selector. And the way these are wired, the voltage comes up to the channel selector. Some of the pins go down to program the PLL chip, and other ones are used for the display here. But you'll have voltage will go through through each of these resistors, and there'll be one for each segment, and a segment is every little line on these displays. That's why they're called 7-segment, because if you count them, there's 1, 2, 3, 4, 5, 6, 7. Now actually these are 8 because they have a decimal point, and then this is a dual package, but there's actually one of these wires is going to go to each one of those segments. So if you don't have the voltage even getting it to the resistor, there's a chance it's a bad channel selector. Rare, but it does happen. So if the voltage is getting out of the channel selector through that network resistor, then your problem is out here somewhere. You can check with a voltmeter. You don't need big fancy equipment to do that. You can just use the cheapest voltometers you can find are fine, because you're not checking signals or anything. You're just checking for voltage and ground basically. But you can check at each one of the pins on this to see if you're actually getting the voltage to them. And if you've got a pin that's getting voltage and the segment for that associated segment of that display is not lighting, then you know it's a bad display. In the case of this one, the display is fine. I don't even know if I can get this flipped back around here. It's actually, this is tight in here, and this thing with all these wires, the way they're set up, it's actually, and thank God I don't have to change this one, because if I did, the flashlight, as you can see, where most channel selector boards will have off the channel selector board will either be a ribbon cable or individual wires, but they all go to the back side or the edge of the board, and then there'll be circuit traces run out to each of the pins. You can see there's a bunch of pins in there on each side of this, and you'll have traces run out. They didn't do that on this. If you can see, they ran the wires right out to each of the pads, so the only way to get the display out, you have to remove all of the wires so you can get in and unsolder the pins of the display to get the display out. But like I say, I got lucky. It's actually this pin right here is bad. Actually, there's a couple of them that are bad, but it's this one that's not making contact right now, and that's why that one segment that was out is out. Because bad solder joint right here, it's completely cracked the whole way around the pin. I can see there's an air gap around it. So I'll take this little wire tie off here, get the wires separated so I can get down in here with a soldering iron and resolder all those connections. But yeah, it looks like for this one, it actually doesn't need any parts. It'll just be a matter of doing the solder joints, and I'll have that back up. But I thought I'd do a quick video to show displays, some of the common problems, what to look for, how the resistor networks, either single or dual inline package can be a problem, and how to get to them and things not to do so you don't break your knobs, break your faceplates. Especially on rare radios like this, you don't want to go breaking them, so just be careful. It's all low voltage here, so even when you're in here measuring things, it's a mobile radio, it's 12 volts, so you don't have to worry about getting electrocuted. But just use common sense. That's probably one of the biggest things I can say from, most people. I understand there are people out there that have absolutely no common sense, but, try to use common sense when you're taking stuff apart. If it's not coming apart, it's not coming apart for a reason. It's either mechanically stuck like this knob was, and you'll have to get ingenuitive on how to get stuff apart. Or stuff like this faceplate, you get to take all the screws off the outside of it, and it's not coming off. There's something wrong. Don't just be a nitwit and get in there with the biggest pry bar you can find and snap your faceplate in half. Take your time. Look, it's tight, and it may be like the screws in this thing. They're very hard to see and actually hard to get to, but they're in there. Look to see if there's any screws going in from the back side of the faceplate and into that bezel, because that's what was holding this one on. So I hope some of those tips can help you out and maybe prevent you from breaking your radio, and better yet, help you get it fixed.